Okay, for today's lesson 5-7, you should have out your notebooks and last night's homework. Again, you should have out already your notebooks and last night's homework. 5-6, I am going to go over a few homework problems before getting started on today's lesson. So the problems that I've picked out are from 5-6, page 373, and I will be doing numbers 30, 34, and 39. All right, starting off with number 30. All right, root 2 sine x plus 1 equals 0. Trying to isolate the sine x, so we're going to subtract the 1, which gives me root 2 sine x equals -1. What would the next step be for us to get the sine x by itself? Good job. We divide by root 2. Which gives me sine x equals -1 over root 2. Now, I'm hoping you're processing and thinking, what is my reference angle? Ignore the negative. Sine of what angle is 1 over root 2? We should all have that memorized as 45. Now, would 45 be one of my answers? Should it be, because there's a negative here, which means I'm not in quadrant 1. All students take calculus. Sine is negative in the bottom 2. So what is 45 in quadrant 3 and quadrant 4? Think about it. I'll give you guys a few seconds to get those answers. Correct. 225 degrees and 315 degrees. And again, the book had them in radians, so if you did those instead, that would be 5 pi over 4 for quadrant 3 and 7 pi over 4 for quadrant 4. So you don't have to write both sets, you choose. Okay, 34. 3 cotangent squared x minus 1 equals 0. I'm going to do the same thing I did on the last one. I'm going to add the 1, which gives me cotangent squared x equals 1. Then I'm going to divide the 3. And divided the 3 prematurely. There should be a 3 here, and that's the piece crossing out. Sorry, going too fast. All right, so cotangent squared x is still there, equals 1/3. Now the next step is up to you. You can reciprocal both sides, or you could square root both sides first. It doesn't matter. You're going to do both steps eventually. I'm going to reciprocal and then square root. Again, you could square root and then reciprocal. I'm reciprocaling because we have sine, cosine, and tangent memorized in our unit circle. So cotangent's the reciprocal of tangent. So when I flip it, I flip both sides. Tan squared x equals 3. The reciprocal of cotangent squared is tangent squared. The reciprocal of 1/3 is 3. All right, so we square root both sides, square root both sides. Don't forget, when you square root both sides, there's a plus or minus in front of your radical. So you're thinking, what's the reference angle? When is y over x root 3 over 1? Here's the y, here's the x. Root 3 over 1 would happen here, which is at 60 degrees. Again, or you're using your unit circle. All right, so we've done these before. We did them last night or yesterday in notes. You did them last night in homework. Which quadrants are you in if you have a plus or minus? Good. I'm hoping you said all 4, because there's 2 places where tangent is positive and 2 places where tangent is negative, so all 4 quadrants. So you're finding 60 degrees in all 4. Quadrant 1 is the obvious 60. Quadrant 2 is 120. Quadrant 3, 180 plus 60 is 240. And in quadrant 4, 360 minus 60 is 300. All right, the last one I'm going to do is 39. Cosecant squared x equals 2. So again, getting practice with the reciprocaling both sides. If they're saying cosecant squared x is 2, that's the same thing as saying sine squared x is 1/2. Why? Because the reciprocal of cosecant squared is sine squared, and the reciprocal of 2 is 1/2. All right, what do we do to both sides? Square root, square root. Don't forget your plus or minus. Sine of x equals plus or minus. Square root of 1 is 1. Root 2 is root 2. And we did one like this just on the other page. I'm hoping you remember that this is reference angle of 45 degrees. Which quadrants are you in if it's plus or minus? All 4. 45 degrees in quadrant 1. What is 45 degrees in quadrant 2? 180 subtract 45 is 135. In quadrant 3, it's 180 plus 45, which is, good, 225. And last, 360 minus 45 would be, correct, 315. And again, for those of you that like your radians, if you choose to, that would be pi over 4, 3 pi over 4, 5 pi over 4, and last one, 7 pi over 4. Okay, that's it for that. I'm going to have you put this aside and take out your notebooks. Again, I'm going to have you put this aside and take out your notebooks. Okay, today's lesson is 5-7. Solving trig equations continued. Solving trig equations continued. And today's date is the 7th. Okay, same as yesterday, we're going to solve for x where 0 degrees is less than or equal to x, which is less than 360 degrees. And just a quick review, we talked about this yesterday. You would see it like this, 0, 360, or with 0 to 2 pi instead of 0 to 360. Okay, number 1. Two sine x plus cosecant x equals 0. 2 sine x plus cosecant x equals 0. So you're looking at this and you're wondering, what do I do? How do I solve this? Thoughts, I'll give you guys a few seconds to think and process. Okay, so we are still using our tricks to try that we had written down in our notes from some time ago. Still using those, so I can't factor here, there's nothing to distribute, but I can change everything to sine and cosine. There's no Pythagorean identities because there's nothing squared. Alright, so 2 sine x, just state 2 sine x. Cosecant, reciprocal of cosecant is, or not reciprocal, cosecant equals 1 over sine. Cosecant equals 1 over sine. And the 0 stays. Alright, so we're going to multiply to clear, and you clear a fractional equation by multiplying everything by sine of x. Okay, so first piece, you end up with 2 sine x times sine x is 2 sine squared x, plus that crosses out, you're left with 1 equals 0. I'm going to give you a few seconds to solve, subtract, divide. I'm hoping you can do that all in one step. If not, that is perfectly fine. Sine squared x equals -1 divided by 2. And what do we do to both sides to solve? Good job. Square root both sides, not forgetting to put your plus and minus in front of the square root. Can we take the square root of a negative? We talked about this yesterday. Yes, if you're using imaginaries, and when you're using real solutions, which is what we're using here, between 0 to 360, there's no real solution. If you just put no solution, that is fine. I know I did that yesterday, and that is perfectly fine. No real solution. Alright, so that's pretty much review from what we did yesterday. Number 2, more review, but a little bit harder, and kids struggle with this one on the test. Alright, here it is. 2 sine squared x plus 3 sine x plus 1 equals 0. Alright, in years past, I would just chug right through it and work it out and had everyone understand and say, okay, we're good, moved on. But there were a few kids who didn't quite get it and would struggle on the test. But once I showed them U substitution, they were like, oh, it's so much easier. So I will be showing this with U substitution, but know that if you don't need it, don't use it, and go straight in to factoring. Okay, so if you don't use U substitution, I hope you can recognize that this is a trinomial guess and check. 2u squared plus 3u plus 1 equals 0. All right, so here goes the substitution. Let u equal sine of x, not sine squared, just sine of x. And if I do that, 2 stays 2, sine squared x would be u squared, plus 3 sine x is u, plus 1 equals 0. Now again, once I told the kids who were struggling, like, hey, just put u in there, they looked at this and said, oh, that's so much easier. So if you like this method, do it. If you don't like this method and you can go straight to double bubble and factoring that, go for it. That's perfectly fine as well. All right, so here's my double bubble. Here's my equal 0. I know that has to be a 2u and a u because that's the only way to get 2u squared. I know this has to be a 1 and a 1 because that's the only way to get the 1. Even easier, this last sign is positive, which means my two signs are the same. And I look here to tell me that they are both positive. So not a whole lot of guessing on this one. Everything pretty much worked out. But don't forget how to do your check. 1 times u is 1u. 2u times 1 is 2u. And 1u plus 2u is 3u, check, positive 3u is in the middle. All right, here it's up to you. You can plug the sine x back in right now and then solve, or you can solve and then plug back in, your choice. I am going to solve and then plug back in. 2u plus 1 equals 0, u plus 1 equals 0. I'm going to do this all in one step. Subtract 1, divide by 2. And this is just subtract 1. So u equals negative 1/2, and u equals negative 1. Okay, we are not done, but I just want to make sure that everyone understands what's been done. I substituted u in for all the sine x's, so 2u squared, 3u plus 1, double bubbled. You'd learned this back in Math 2. You did it again last year. We reviewed it beginning of this school year. Guess and check. Did our work. Here's our checking, check. Solved equals 0 equals 0 using the zero product property. Solved and solved. And now I'm at the point where I will be plugging the sine x back in for the u's. Because if you gave me these two answers on the test, that would be wrong. So it is sine x equals negative 1/2 and sine x equals negative 1. Okay, so here's your thinking bubble. When is sine 1/2? Ignoring the negative. 30 degrees, I'm hoping you remember, is your reference angle. Sine of 30 is 1/2. So negative, my sine is negative in the bottom two quadrants. So what is 30 degrees in those two quadrants? 210 and 330 for quadrant 4. Sine of x is negative 1. When is sine negative 1? There's 0, 1, and there's 0, negative 1. It happens at 270 degrees. Okay, number 3. Two sine squared x equals 2 plus cosine x. Okay, so where do we start? Now I'm looking at this and I'm like, okay, nothing I can do with it in the form it's in right now. So I'm going to at least try to get it equal to 0 to see if I can do anything from there. So 2 sine squared x minus the cosine x minus the 2 equals 0. Do you see what I've done? I moved the cosine x over and the 2 over, and this is what I have. All right, cannot factor it the way it is. So I'm looking, can I use any identities? I can't use reciprocal identities because that's changing everything to sine and cosine, and that's already done. Now I'm going to use a Pythagorean identity, and I want you to recognize that the only choice I have is to change this one right here. Now we did one the other day, yesterday. Let's see if I can find it. I'm going to move this over really quick. This was yesterday's lesson, the last one from yesterday's lesson. When I moved it over, and I hope you remember me saying, oh, it doesn't matter which one you pick either one. I'm picking the first one because I don't want to have to worry about distributing a -3. So I changed it and we moved on. And that is correct. It does not matter which one you choose in this case because they're both quantity squared. In this case, we don't have that same choice. We can't say, oh, it doesn't matter because they're not both squared. Cosine x is just cosine x, and cosine x by itself, we cannot use a Pythagorean identity, but sine squared we can. So I'm going to write it like this: 2 parentheses minus cosine x minus 2 equals 0. And what does sine squared equal? 1 minus cosine squared x. And I'm going to let you guys continue this on your own. Distribute the 2, combine like terms, and factor.